Hi everyone, in this lecture we are going to study about solution for potential function. So in this lecture we are given a current distribution over an antenna, and what we need to do is we just need to determine the electric and magnetic field equation due to this current distribution which is present over the antenna. But here is one important condition. This condition says that the electric and magnetic field should satisfy this Maxwell's equation. In the previous lecture also we have discussed the four Maxwell's equation. So this electric and magnetic field equation should also satisfy that four Maxwell's equation. So step by step we will solve the electric and magnetic field equation, and then we will satisfy all the four Maxwell's equation. So this is all about this lecture. Let's begin with the first condition. Since we know that the divergence of a curl of a vector field is equals to 0 only. So this is our first step. That's why we write it as a divergence of curl of a vector field is 0 always. This is the fact that we all know. Okay, so according to this fact we can say that divergence of del cross A, that is curl, will be equals to 0. Let me give it as equation number 1. And from the Maxwell's second equation that we discussed, from Maxwell's second equation we can say that del dot B will be always equals to 0 only. Let me give it as equation number 2. If we compare this equation number 1 and equation number 2, then on comparing equation 1 and equation 2, we can say that B will be equals to this del cross A, because both these equation will be equals to 0 only. That's why we can say that B equals to del cross A. And we also know that the value of B is nothing but equals to the product of mu and H. So from this we can easily say that mu H will be equals to this del cross A. And from this is our equation number 3rd. And if we rewrite this equation number 3rd, then we can also write it as H, that will be equals to 1 over mu in multiplication with del cross A. So this is the equation for the magnetic field. It is equation number 4. And if we talk about this A, then this A represents the magnetic vector potential. So this A is nothing but magnetic vector potential. Okay, and this is the final magnetic field equation, and it satisfies the Maxwell's second equation also. So we can write it as this satisfies Maxwell's second equation. So Maxwell's second equation is satisfied easily. Okay, let's come on to the next step. So in the next step we will satisfy Maxwell's third equation. So we know that from Maxwell's third equation, we can say that del cross E, that will be equals to minus of j omega mu h. And also from the equation number 3, we can say that the value of mu h is nothing but del cross A. So from equation number 3, we can say that del cross E, that will be equals to minus of j omega, and in place of mu h we will write del cross A. So here is del cross A. Okay. Now if we shift it in the left hand side, then taking the del as a common factor, we can write it as del cross E plus j omega A, that will be equals to 0 only. And let me give it as equation number 5. Since we know that the curl of a gradient of a scalar function is always be as 0, so since curl of gradient of scalar function is 0 only, so we can write it as del cross del dot v, that will be equals to 0, because here v is a scalar function and here is a curl of divergence of scalar function, so it is equals to 0. And let me give it as equation number 6. On comparing equation number 5 and equation number 6, we can say that on comparing equation 5 and equation 6, we can say that the value of E plus j omega A, that will be equals to minus of del V. And if we shift it, then the value of the electric field will be equals to E equals to minus as a common factor, then del V plus j omega A. And this is the expression for the electric field. Let me give it as equation number 7. And this finally satisfies Maxwell's third equation. So we can write it as this satisfies Maxwell's third equation. So till now Maxwell's second equation and Maxwell's third equation is satisfied, and we will also satisfy the remaining two equations, that is first equation and fourth equation of Maxwell. So these are the two equations, first for the magnetic field and second for the electric field, that we derived, that is equation number 4 and equation number 7. Let's satisfy the another Maxwell equation. So this is our third step, in which we will satisfy the Maxwell's fourth equation. So from Maxwell's fourth equation, we can say that del cross H, that is nothing but equals to j omega epsilon into E plus J. Now from fourth and seventh equation, we get from equation number 4 and equation number 7, we can write it as, by putting the value in place of H, we will write this whole thing, that is 1 over mu del cross A equals to j omega epsilon. In place of E we will write this whole thing. So minus of in bracket del V plus j omega A and plus j as it is. Now if we open this bracket, then it will look like 1 over mu del cross A, that will be equals to minus of j omega epsilon del V plus j omega A plus j. We all know that the vector identity says that if any expression is written as del cross A, then it will be equals to del divergence of A minus of del 2A. So this is nothing but vector identity, and we will use this expression here. So simply replacing this expression by here, we will write 1 over mu. In place of this we will write this expression. So del divergence of A minus del 2A, and it will be equals to minus of j omega epsilon, then plus j omega A plus j. Now if we rearrange these terms, then it will look like this, that is divergence of A minus of del 2A, that will be equals to this 1 over mu will get cross multiplication in the RHS side, so it will become minus of j omega mu epsilon del V plus omega square mu epsilon A plus j mu. Now if we solve it, then this expression will further become equals to minus of j mu taken in the LHS plus del gradient of A plus j omega mu epsilon in multiplication with del V, that will be equals to this omega square mu epsilon A plus del 2A. Now this term can also be rewritten as equals to del 2A plus omega square mu epsilon into A, and remaining terms will be shifted into the RHS side. So minus of j mu plus del divergence of A plus j omega mu epsilon into A. This is our equation number 8. And we can say that this expression, that is equation number 8, satisfies Maxwell's fourth equation. So it satisfies Maxwell's fourth equation. Now Maxwell's first equation is remaining, so we will also satisfy it. Now for the next step, we should equate this bracket to the 0 such that the value of del dot A will be equals to minus of j omega mu epsilon into A. So it is our next step. So from equation number 8, we can say that the value of del dot A, that will be equals to minus of j omega mu epsilon into V. Sorry, here is one correction in the equation number 8, that is in place of A here is V, capital V, that is scalar function. That's why when we equate this bracket equals to 0, then the value of del dot A will be equals to minus of j omega mu epsilon into V, that is this equation. Now we also know that the value of del 2 into A plus omega square mu epsilon into A, that will be equals to minus of j mu, and if we rewrite it, then we can write it as del 2A plus k square A, that will be equals to minus of j mu, because we know that the value of k is nothing but equals to omega under the root mu epsilon. So the value of k square, that will be equals to omega square mu epsilon. That's why in place of this omega square mu epsilon, we write here is k square. Okay, so let me give it as equation number 10. So this is our equation number 10. Now from the Maxwell's first equation, we can say that del dot D, that will be equals to rho only, and we know that the value of D is equals to epsilon into E. So if we replace it by the epsilon into E value, then the value become del dot epsilon E, that will be equals to rho. If we shift this epsilon in the denominator, then it become del dot E equals to rho over epsilon. Now from the equation number 7 that we discussed, by simply putting the value of E in this equation, we can rewrite it as, from equation number 7, it will become minus of del, here is the minus sign, that will be copied here, del V plus j omega A, that will be equals to rho over epsilon. So del 2 V plus j omega del dot A will be equals to minus of rho over epsilon. Now from the equation number 9 that we discussed, here is the equation number 9. So from this equation we can easily say that from equation number 9 we can rewrite this equation as del 2V plus j omega, and in place of this del dot A we will simply write this equation, that is minus of j omega mu epsilon into V, and this RHS part is as it is, so it will be equals to minus of rho over epsilon. If we simplify this equation, then it will be rewritten as del 2V plus omega square mu epsilon into V equals to minus of rho over epsilon. And if we let the value of k equals to omega under the root mu epsilon, then this equation will be written as del 2V plus k square in multiplication with V equals to minus of rho over epsilon, and this is our final equation. And we can say that Maxwell's first equation is also satisfied. So Maxwell's first equation is satisfied. So in this way, we satisfied the electric and magnetic field equation by all the 4 Maxwell's equation. This is all about our topic, that is solution for potential function. If you like my content, then do subscribe my channel and please hit the like button. Thank you and goodbye.